warm introduction. So generative AI and productivity gain is what we are going to speak about today. So in today's paper presentation, we'll walk you through a solution which we developed for a data migration project, wherein we leverage generative AI to augment the work and activities of data engineers, right? So to give you the requirement context, the requirement was to merge together the reports and the data, which is spread across multiple BI systems into a unified reporting portal, as well as bring it into unified data platform, right? So in order to do that, the data engineers are expected to deep dive into each of the reports, right? Understand what is the business logic, what are the procedures, what is the rules and transformation the data is going through. Basically, they have to analyze and trace back the entire journey from the start till the end, right? And if we speak about these BI systems, these are legacy systems, right? So that means they already have approximately 15 to 20,000 of data objects when we are speaking about them. And when we speak about data objects, we are talking about the SQL statements, the procedures, the triggers, and the functions. And they have to actually analyze and spend time on doing that analysis. So what we did is we actually created a solution where we ingested all the procedures, functions, the DDL and the DML script, and leveraging generative AI, we actually contextualized it and made it in a format which is consumable from the data engineer's perspective, right? So that they just focus on what should be the migration strategy, and everything else we actually streamline for them. So now we'll actually deep dive into each of the components, which is one contextual layer, the consumption layer, and speak about the design decisions which we took while developing the solution. So I'll hand it over to Vikas to actually continue with that solution.
Thank you, Shakuntala. Thanks for setting the context. Hi, everyone. My name is Vikas Sinha. I'm an AI consulting manager at EY. So I'll be walking you through the rest part of the story. I'll begin by saying that we have already reached an inflection point, right? So where the data is huge, vast, complex, unstructured, and continuously evolving, right? And in that case, understanding the data provenance, tracing the traceability of it and ensuring the traceability of it and maintaining the compliance of it is no more an option. It has become a necessity, right? So when we say that it has become a necessity, we have kind of enabled these outcomes for our user, basically depending upon three key pillars of our solution approach. The first one was having one contextual layer, another is having a retrieval mechanism, and the consumption layer, all of them being orchestrated through an custom orchestrator. Okay, so contextual layer, just to give you a brief, contextual layer basically helps properly indexing your objects and making it searchable. Retrieval mechanism basically helps fetching the right results efficiently, and the consumption layer helps in taking your input, processing it, and then giving you an output which is more insightful and in much more structured fashion. So let's deep dive into each one of them in our next slide, and I'll be speaking on it. I'll be also also discussing the challenges which we met on designing each one of them and how we mitigated it. So as you can see on the extreme left, we have multiple business functions, and each of those multiple business functions were having multiple databases, right? So some were having SQL, some were having Oracles, and other like that, and lots of databases, schemas, and your SQL objects, which includes procedures, functions, views, triggers, all those things. So these are all set of DDLs and the DML scripts. Nothing has to do with the data in it, right? So we want, because the aim is to define the legacy or backtrack it and find out what is the root cause or the root table which is supplying its data to the final UI layer. So we had a set of procedure scripts, functions, and all those things, and how we were provided was, it was one script per object type. That means one file which was containing like around 10 to 20,000 procedures, one file which was containing equal amount of functions, one file, views, like this thing. So the very first challenge what we met was that how do we reduce the size, how do we chunk it, right? So there were two strategies which we followed for chunking. First is simple, the size thing. So we'll try to keep this thing into 2 MB file size, but also making sure that the integrity of any of the SQL objects, or in such case Oracle objects, remains unimpacted. So it retains its integrity, right? So nothing is cut middle way. So in that case, what we were doing is that we made a use of, finally we are looping through it, size things and bucketing it into a fixed size 2 MB file, or near about the same thing. But we have made use of the robust and scalable regular expressions, which will also make sure to find the logical ending of any SQL object, right? So if in case your 2 MB file size grows up and something is getting cut midway, it will not allow it thing. So it will allow that thing to go into a separate file. Now another challenge was, suppose if any of the file or any of the procedure is too huge, which was in our case, something around 150,000 tokens were there, exceeding any of the large language model context window as well. Okay, so that also we'll see. So when these lengthy things were there, we relaxed our rule number 1, saying that okay, if the size is more than, while maintaining the integrity, if the size is more than 2 MB, let it grow in 3 or 4 MB size and let that be there. Can we zoom in into that, please? The first one. Right. So if you see on the top hand, right hand, left hand side, you have all these functions, and there are lots of files. And these are the chunked ones, which nearly 2 MB files or 2 KB file size over here, right? So everything has been reduced to that limit. If something is growing, it takes one file of itself. Okay. Can we zoom out? Thank you. Next thing was that once we have done this thing, we have to encrypt the data. So because we have to maintain the data privacy, preserve the privacy of the data as well, one of the responsible AI pillars of maintaining the data security, we are encrypting it and storing it into one or the other layers in our Azure data lake. Okay, so when we are doing that thing, we are making sure that each and everything is marked as well, because these are pretty old written procedures, functions and everything, like 20-30 years old system, and many developers would have tried their hands. They have created their own copies of themselves, _test, _old, _datetime, _developer name, right? A lot of variations, complexities were there in over here. And they were also having somewhere hard-coded phone numbers, customer service email address, business functions name, the business functions key person names, all of them were there. So we used Azure language service over here, and we anonymized all of those texts as well, right? So that is another activity which we have done. Next thing is that we wanted to fetch the metadata of it. So more of the metadata so as to support the the search accuracy. The searching thing gets more accurate as in, when you provide more and more of the metadata to it. What we did over here is that, can we zoom in once more on the same one? So what we did is that in each of these stored procedures, what we found it is that what all other procedures, functions, views, tables, all those mentions of the things, common table expressions, dynamic variables, all those things we are capturing as a separate objects over here. And then we are also tokenizing it so that, the processing becomes a bit faster. So all those things we have also taken it out over here. Zoom out, please. Backs. Right. So those things, text analytics helps with generating the metadata. Now comes the embedding and the indexing part. So we could have directly also indexed it, because it was all the textual thing, semantic thing would be working very well. And we could have simply the stored procedure, text, body and everything, whatever we have created, we can simply index it also. But here, what we have tried to do is that we have done an additional layer of embedding, which is giving an uplift of around 6 to 7% accuracy search results. Okay, we are doing embedding using text-3 large language model, embedding model, okay, and also have compressed the size. That means the dimensions are just 256 compared to the default, which was around 1500 something. So we have compressed it, because since it is all code-based, we wanted all the semantically similar tokens and all those things to appear in much closer to each other. And that's the thing what we followed over here. We decreased the the size, the dimensions of the embedding, and then we have indexed it. So that means now our index is having the textual things as well as the embedding, so that it is helping us support the hybrid search, right? So it will have the semantic search, simple search, and the hybrid search as well. This is how we have created our contextual layer, and why we are calling it specifically as one contextual layer. Reason being, now different business functions can have their own databases and all those things, and with just a small tweaks in the regular expressions or wherever we have used, we can simply use the same code base to create or enrich our existing contextual layer. So it becomes literally an enterprise wide one contextual layer using this thing. Now the other half of it is the consumption layer, right? So consumption layer is where the people are, the end users will be sending in their prompts, and it will be processed and the results will get generated. Now another catch over here is that the challenge which we met is that, so if you see table name, so what happens is that you can provide just the table name, that I want a lineage of this particular table, or you can say I want the lineage of schema.table name, or you can also say I want the lineage of database.schema.table name. All of them essentially is just one thing. It is referencing to the one single thing, which is that table name, right? So for which we wanted to calculate the lineage. But this is also a challenge which we have to manage, and we have to make it consistent across all the things. That's where we are also doing a little bit of augmentation. But before augmentation, what the user sends, we are first doing the prompt validations. So another principle of responsible AI is that, profanity check and, any toxicity words and all those things. So small validation things also happens on the input prompts. Then it goes for the augmentation. Now, another thing is that, for example, if I want to calculate the lineage of table T, okay, we say, okay, find the lineage of table T. Now, what does that mean? I mean, wherever this particular table is getting its data from or into, right? It has nothing to do with where is this table is being used downstream in a form of a select query. That means it should be followed by insert into, or update, or select into. So these three keywords are something most important in finding the lineage or the source of data population for this particular table. So we have done the data or query or augmentation, where we have used Lucene query syntax with proximity search of 5-word tokens. Meaning what? In a 5-word token, here or there, if you are able to find this table and insert into, select into, or update kind of query, pick up those procedures or those places where it has been defined. So that means it is over here itself eliminating all those places where this table is just being used in the select query. So select everything holds no meaning for the lineage purpose, right? So that is something what we have taken care in the query augmentation. So once we have augmented it, we are sending the same Lucene text query to our Azure search index, where it does the job of query retrieval. Now, since there is a whole lot of contextual layer which we have created using metadata and embedding and all those things, it is getting us back the results. And Azure Search Index out of the box also provides the re-ranking. But over here, there are, since we are using regular expressions, and I've said this thing that the data is constantly evolving, right? So we are not touching this portion. We are always touching contextual layer whenever new data comes or new data sets we receive. So when this happens, regular expressions tweaking also sometimes fails in capturing out all the redundant entities like underscore test, underscore old, underscore developer name or time frame or something like that. So we re-rank it once more over here and put down subpower all those kinds of results, okay, which are more or less coming from those redundant procedures or the SQL objects, right? So that is the re-ranking, custom re-ranking, which we have applied at the retrieval stage. Then comes the prompt engineering. Before sending it to the LLM call the retrieved results from the search, we do the prompt engineering. Can we zoom in, please, on that? So is this one. So our our prompt design strategy was just a 3-phase strategy, okay? Where first of all we are saying identify all the contributing objects. That means all the contributing objects, tables which are supplying its data to this particular table, okay? That means they are helping populate one or the other fields of this particular table. Be it if there are common table expressions, contains all those things. So do not name just the common table expressions or the aliases or the dynamic variables. Rather go and scrap further and get the real object name outside, right? So all those things are handled using that particular piece of thing. So next is, suppose this GenAI is giving you some results. Now, how do you verify it's right or wrong, right? So there is this accountability principle of responsible AI where you need to know, okay, you have generated this result. How should I believe? So to ensure that trust or entrust the users, we are taking the help of these two prompts as well. Now, first is fetch the code snippet where you have found this whole thing happening. That means give me the set of that code snippet out of the large SQL objects where this particular table is getting inserted into, created into, or something like that, updated into, right? And also help me with the attributes. So simply saying that, okay, table Y is populating, is helping populate the data into table T is not enough, right? You need to know which all columns, like, because there is no one-on-one mapping that everything of this table goes into everything of that table, right? So over there, what all columns, what all attributes are basically helping you put into the things, give me that result set as well. Now these two helps do a lot of reconciliation thing on its own. It lifts the load from the developers or the end users, saying that, okay, you need not to go and revalidate the things once more. You just go to the reconciliation part, the outcome into it, and just see whether your code snippet is having that thing or no, or your columns are properly coming or no, right? There could be a direct columns, direct attributes. There could be an calculated attributes as well. So everything comes up over here. I have also taken help of some regular expressions, very minimal. When I'll be explaining the next part, which is the the LLM model selections, I'll put a focus on why there was more of the examples and some things required in the form of regular expressions for the older generations of the LLMs which I have used. So this is how I have designed the prompt. Can we zoom out, please? So we have come here till here. The retrieval is happening. The prompts has been created. Now the next step is to send it to the model, right? So we started with the one model which was GPT-4 32K. The context window anyways is 32,000 tokens. But our data set, many of the procedures were more than like 80,000 or 90,000 or even going till 150K tokens. So we have to do a lot of context or the results from the previous thing. We have to hold it back and send it as a new context in the subsequent executions. And that was, somewhere it was also, not working that much well because it will lose or it will have the redundant informations. Plus, GPT-4 32K required a lot of examples to be given. Almost all the kinds, okay, you go and find out insert into, you go and find out select into, you go and find out update. You also have to give what not to include, like do not include anything which comes as select everything, right? Select asterisk or something like that. So we have to give what you have to include, what you have to exclude. So everything you have to mention it very explicitly over there. We then switched to GPT-4o. Okay, now that helped solve this problem. So with the GPT-4o, we require very minimal, prompt instructions. Very minimal. I have not given it any examples. I have not given it anything, not regular expressions to get the contributing objects. It is doing everything on its own, and the accuracy is very high on this one using GPT-4o. Plus, it has a context window of around 128K tokens. So the largest of the procedure is just getting executed in maximum 2 or 3 iterations. So holding back the context is also solved over there, and it is also not taking like redundant informations or all those things has been avoided using GPT-4o model. Okay. Now next comes is once you send the results, it gives you back the results. What we have to do is that we have to do the output reformatting. Reformatting because it's all the textual things what the GenAI is sending, right? We have to reformat it into user consumable format. So we are consuming it, we are converting it into 2 formats. One is JSON and another is data frame kind of thing, so that it could directly be exported into an Excel, and the hierarchies and the levels, parent and the child, or the contributing objects, and the reconciliation sheets also we can see one after the other directly over there. And using these 2 things, we are well able to generate the graph kind of visualization as well, which is a tree format thing. We are able to properly generate it. Now we have applied all of these things, making sure that there is a proper data governance, proper security thing is taken care, and proper deployment also happens, scalable deployment and robust deployment. So can we zoom in into that data governance and security? So with the data governance and security, what we are doing is that we have lots of intermittent results which we are saving, right? So it's a huge data set. We don't want to lose it, or we don't want to rerun it again and again. So we are saving it intermittently. And when we are saving it intermittently, we are making sure proper encryption, decryption, anonymization, all things are there. Plus, there is a role-based access control that only the people who are using it with the proper service principal account and access and all those things, role-based things, are able to access it, the outcomes, the intermittent outcomes, the final outcomes, all those things. And then on the deployment side, we have used Azure Kubernetes containerized deployment, which is anyways isolated. So it is all kind of watertight case in case of any from any threats or something like that. So that thing also we have taken care very well over here throughout the solution, not just one part, equally distributed across everywhere. So user input I have already taken care that validations also happen, filterings happen, the response which gets generated also gets validated before sending it or preparing the final responses. So that thing is there. Can we zoom out, please? This thing, now this whole code which is created is very much modularized, so that everything, whatever parts you are able to see up over here, everything is converted into a modular classes object fashion, right? So that, and it also follows these solid programming principles. If you all know, you would be knowing it. Solid stands for the single responsibility, then Liskov substitution, and inverse dependencies and all those things, right? So all of those things has been taken care. Open for extension but closed for modifications, so that it can be adopted to new data set, new things which are coming up, but the old one remains as it is. So derived class, abstract class, base class, everything has been taken care of while the coding thing. So this is how we have basically developed our solution, following all the best practices on the responsible AI side, educate responsible AI implementations, governance implementation, security, and then Python programming best practices. Next is, with all of this, so these are some of the challenges which I was speaking about, that redundant objects were there, 20,000 parsing 20,000 things with deviations and complex things such as CTs and then dynamic queries and whatnot, all there. So handling those things. Multiple embedding models we have tested, but because this is a coding based thing, so we required a very dense, densely populated embeddings to happen, not a sparse one, because then it will not help us with proper retrieval accuracy and all those things. Custom re-ranking, as explained to you. Partial queries, the same thing. People might be sending simple table name, or they may be sending the schema or table name or database name. Setting the right, selecting the right GenAI model helped me a lot over here. And deployment is like optimized and scalable deployment, Kubernetes and all those things we have used. Now this all has helped me gain an accuracy of around 85 to 93%, right? So why 85 and 93? Because the object complexity is very much. So they are having around 20,000 objects. Not all of them are of equal size, right? There are very, very huge legacy SQL procedures, functions, and all those things which are like very, very complex, and whatnot you can imagine into that is available over there. Over there, we have been able to achieve a pretty well 85 to 90% accuracy. But there are a few smaller ones, very smaller ones, 10,000, 20,000 tokens, some median ones which are around 50,000, 60,000 tokens. Over there, we have been able to achieve an accuracy of 93%. Now, this is all benchmarked against the manual lineage which on the parallel side, the data engineers and developers were doing. So this has been benchmarked against that thing. The major gain was on this one, the efficiency in time saving. So we have been able to save the developers' time, the modelers' time, the engineers' time by 96%. Whatever they have been doing for one single object, they will pick it up. They would be taking around 5 to 6 hours to trace back across these 20,000, 25,000 objects and come with the legacy, and then also revalidate it once again by a peer programming or something. They are now left reduced to just max to max half an hour, including the validations, because this GenAI is helping them generate the results for a particular object in just like the biggest of them in just like 5 to 7 or 8 minutes. right? And you can give a club of them. That means you need not to do it one by one. You can say 10 objects, provide me the lineage of 10 objects. You give it and forget about it. Within 30 minutes, it will give you all the things. Only thing which the user has to do is randomly go and check it, whether it is fine or not, which we have tested it and it's all good, well within the limits. So this is how, you know, we have been able to generate the graph of it. So you will have the top level and then all the bottom levels. Now this has one more thing, which is you can usually do is the impact analysis part of it, right? So what do we mean by impact analysis? If you remove one of the layers somewhere, your entire stack falls, right? So that means it will help you determine what are my upstreams and what are my downstreams which will get impacted if I remove or forget to migrate one of the important objects from old system to new system or something like that, right? So that is something which will be taken care. And these are all the Excel outcomes, I'm sure pretty blurred up, but then some reconciliations, some things over here. Now this is what we wanted to cover, and happy to have any questions. The floor is open for discussions. Yeah.
Thank you. Can somebody pass on the mic here, please? Second row.
Hi. So as you mentioned, I see you have used this OpenAI text embedding 3 large model for this embedding purpose, right? So what I want to know is, like, by default it is, I think, 1536 or something, the vector dimension, and it can maximum go to
1536, right?
Yeah, 3072 is the maximum, but you have used 256 in order to make it a dense vector, right?
More dense, right?
Yeah. So have you seen any enhancement in the precision or recall of the retrieval?
Right. So we have seen that thing, because when you have a sparse embeddings, what happens is that your search accuracy decreases, because we are doing the hybrid search, and it definitely gives you affects your 2 to 3% of accuracy when you have the sparse thing, because in a code-based thing, you require all the relevant or syntactically similar, semantically similar things to be as close as possible to each other. If you are having, like for example, take this example, insert into this table. If insert into is in one corner, this table is in another corner, embedding has lot of things, gaps or the sparse thing, it's not going to give you the right, bring down the right result to it. But if you have compress it, it is going to give you the right results, better results in fact.
Okay. So how did you arrive at this number, from 3072 all the way down to?
So I tried with multiple things. I even tried with PCA to further decrease it down, but that was not giving me that much uplift to the procedure, and that was a more computational intensive, because I'm first of all reducing it and then again doing PCA. That this whole thing costed me time and the resources.
So you've basically done a quantitative analysis as to
right. So a lot of decision making steps were there, so we went through that experimentation stage.
Thank you.
So the accuracy here means, right, what is the table that is being plotted? Is that table
accuracy over here means, suppose you are finding the lineage of a particular table, right? So that means this table is getting populated based upon what other tables. So accuracy over here is
the source table name is
all source table names, and backtrack to 7, 8, 5, 7 levels, whatever configurable configurations we have given. Right now we have given it 8 configurations, so it goes back 8 levels back if it is possible. Otherwise, if it has found the leaf node at around 4th level or 5th level or 6th level, it ends over there. It doesn't hallucinate or tries to generate the things.
Okay, thank you.
And accuracy was, again, I've told you, so we benchmarked it against the manual things what the data engineers were parallelly doing it. So how much tables they were able to find out, and how much table GenAI solution was able to find out. Plus, one more thing what we have noticed is that they have added more tables wrongly in their outcomes, but GenAI did not do that. Okay. So this was much more closer to the lineage thing.
Got it. Yeah.
Yes,
thank you.
No, knowledge graph I haven't used, because our aim was not to do the relationship finding and all those things. My aim was majorly to flatten up the things, because the data from different systems, the data is coming in, right? My objective was not to create the relationship between the tables or the schemas. My only objective was to flatten up everything, see it together, bird eye view, and find out, okay, how many things are located where. And do it in the fetch it into the retrieval thing.
So this tree diagram that you show here, how is it that this has been generated?
So this is getting generated from these Excel files only. So we have used a proper, this thing, custom visualization thing to generate the parent child, because in our outcome we have the parent, this is the target table, and the contributing objects. So contributing objects becomes the level down. This becomes the parent, contributing objects, this, contributing objects, like this. Yeah.
We'll take one last question if anyone has.
That one I don't think so it's zoomable. These are static images. Tokenization. So tokenization in the sense, the embedding. So we have used embedding, Azure embedding model. This Azure 3 large embeddings. That is the model name. So over there, it allows to change your dimensions. So that's where I was able. So by default, it provides 1536 as a dimension. Over there, it allowed me to change the dimension. I made it to 256. Sorry? Parallelly also we can do, but I also wanted to, that's the minimum limit over there. And we can also go very, very, thin also, but that's not going to help us. So it's like overfitting and underfitting, same thing.
Instead of doing these things directly, why can't you hire Azure services and there itself you deploy the databases and there itself you can use it, no?
So which service basically?
OpenAI,
and
we have used Azure services and you deployed your architecture for finding some solution. What I want to say is directly instead of OpenAI or Azure services, one service you take it and directly also you can do it, no?
So a lot of custom codings were done in middle, that there is.
Azure services also will support all these things, data.
I'm using completely the Azure stack only. So one or the other Azure stacks only, or the services we are using.
So the OpenAI which is being mentioned is Azure's OpenAI. So we are actually developed the entire solution using Azure stack.
So it's all Azure, Azure OpenAI deployment. Right, everything is Azure.
I have one question.
I'll end with this question, please. Yeah.
Yeah. So the vector DB or the embedding DB that is getting created at stage 1, it takes input as the DML and DDL queries, right? The input database.
It takes input those metadatas which we have created and the DDLs and the DMLs,
DML queries, right? And let's say you want to get the lineage of a data store, right? A data object. So let's say there's an inconsistency in the language. Basically, there are some missing queries for a lineage, the ground truth of a lineage, right? How will you?
That's the limitation. That's the limitation. So suppose if there is suppose in the input data set itself there is one missing part, then it's not going to go and generate it. So
it stops at some point.
It stops at some point, right? So it finds the leaf node. I am not able to find further track. It stops over there. It doesn't hallucinate. That's more important to know that it doesn't hallucinate or creates the things on its own.
Creates its own lineage.
So it doesn't do that thing. Yes, please.
Thank you. We'll move it outside session. We are running into the next session.
Thank you very much. Thanks all for attending the session.
Thank you. Give them a round of applause. Thank you.